Hello and welcome. Today we're diving deep into a critical topic for building resilient, real-time data systems: manual Kafka partition assignment. In the world of stream processing, especially when dealing with high-volume data like social media posts, simply consuming messages isn't enough. Often you need your processing logic to remember things, to maintain state across messages. Think about tracking trending hashtags, user sessions, or even fraud detection patterns. This requires a stable, predictable environment for your workers. Automatic load balancing, while convenient, can sometimes be an adversary to statefulness. That's where manual partition assignment comes in. It gives you explicit control, allowing you to build sophisticated, stateful processors that can truly understand and react to data over time. By the end of this lesson, you will be able to, first, understand why manual partition assignment is crucial for stateful stream processing. Second, you'll learn how manual assignment works compared to traditional consumer groups. Third, we'll explore its architectural integration in a real-time system, like our StreamSocial trend analysis. And finally, you'll identify practical considerations and best practices for using this powerful technique in production environments. Let's get started. Let's start by understanding why manual assignment is even necessary. Kafka's consumer groups are brilliant for distributing load. They automatically assign partitions to consumers within a group, ensuring messages are processed efficiently. But here's the catch: they're terrible when your processing needs to maintain state. Imagine you're building a system to track trending hashtags for StreamSocial. A worker processes a partition, accumulating data about hashtag frequencies and velocities. If Kafka suddenly reassigns that partition to a different worker during a rebalance event, the original worker loses all its accumulated trend data. The new worker starts from scratch, breaking the continuity of your trend analysis. This is where manual assignment shines. It gives you deterministic partition ownership. You explicitly tell a consumer which partitions it owns, and it keeps them. This trades the convenience of automatic load balancing for the absolute necessity of predictable state management. It's a conscious decision to take on more control for a critical capability. It's a fundamental shift in how you think about consumer responsibility and data continuity. So, how do we actually implement this? The core difference is in how your consumer initializes. Instead of using consumer.subscribe to join a consumer group and let Kafka assign partitions, you directly use consumer.assign and provide a list of specific topic partition objects. Once assigned, your consumer permanently owns these partitions until you explicitly change the assignment. There's no automatic rebalancing, no surprises, just stable ownership. This approach fits perfectly into a real-time pipeline like our StreamSocial trend detection system. Posts flow into partition topics, then our dedicated trend workers, each owning specific partitions, perform stateful processing. Their accumulated state is then persisted, and finally, a global aggregator merges these partition-level trends for comprehensive insights. Think of a real-world parallel. Twitter's trending algorithm likely uses a similar partition affinity. Specific servers or worker processes might track trends for geographic regions or particular topic categories, maintaining a persistent state about hashtag velocity and user engagement within their assigned scope. This allows for highly accurate, localized trend detection without losing context during operational changes. It's a powerful pattern for large-scale stateful data analysis. Let's break down the components and state management within our trend analysis system. Our architecture consists of 4 key players: a partition assignment manager that dictates which worker gets which partition, the stateful trend workers themselves processing their assigned data, a state checkpoint service for persisting their state, and finally, a global trend aggregator to combine insights from all workers. Each trend worker is a sophisticated entity, maintaining crucial local state. This includes a hashtag frequency map for real-time counts, time windows for calculating velocity, and user engagement metrics to identify unique users. These workers move through distinct states. They initialize by loading assignments and historical data, then enter a consuming loop for active message processing. Periodically, they perform checkpointing to persist their state and, if needed, handle rebalancing for manual reassignment. Finally, they ensure a graceful shutdown by preserving state when terminating. This periodic state snapshotting is absolutely crucial for recovery. If a worker fails and restarts, it can rebuild its trend state from the last checkpoint and then efficiently replay any messages from that point forward, ensuring data integrity and continuous trend analysis. Now that we've covered the what and the how, let's talk about the when and the how to avoid pitfalls in a production environment. Manual partition assignment is perfect for specific scenarios: stateful stream processing, like our trending system or recommendation engines, requirements for geographic data locality, ensuring data stays where it's most relevant, and when you need to implement custom load balancing logic. However, it's wise to avoid it when you're doing simple, stateless processing where consumer groups are perfectly adequate. In environments with high worker churn, as manual reassignments add operational overhead, or when automatic scaling is a critical, non-negotiable requirement. There are a few production gotchas to watch out for. State recovery is paramount. Always implement robust state checkpointing. When workers restart, they must rebuild their state from the last checkpoint. Partition count planning is also crucial. Changes to partition counts are complex with manual assignment, so plan your strategy up front. And finally, monitoring is critical. Without consumer groups, you lose automatic lag monitoring, so you'll need to implement custom metrics to track per partition processing lag. To wrap up, remember that manual partition assignment empowers you to build highly specialized, stateful stream processing applications. It's a powerful tool when used thoughtfully. For your self-assessment, consider, how does manual partition assignment enable stateful processing where consumer groups, with their automatic rebalancing, fall short? Reflect on the core differences and the benefits of deterministic ownership. Thank you for joining.